Okay, looks complicated. It's not that complicated. All right, basically what we're doing is now to figure out what the impulse it would be, that's the area under this curve. All right. In other words, what this graph is. All right. Let's take a baseball being hit. Okay. So, and in the video that you see of Major League Baseball, you'll see how the ball gets so deformed. Okay, so right when it's starting to get hit, boink, and then it starts to get deformed and it's smashed in there, and then it's completely smashed. Then it starts to spring out as the swing comes through, and then it leaves the bat, and so there's no more. But there's a maximum time there when it's has this maximum amount of force being applied to it. Comes starting to get hit, and so this time right here, we're talking milliseconds. You know, thousandths of a second is a millisecond. 1 millisecond is 1/1000th of it. So we're talking like 15 milliseconds, or 1.5 hundredths of a second. Is the time of that collision. And when you take a number, and so when you look at so when you're going to find the average force, so we can find the change of momentum easy, and that's the impulse. But then when we divide by a really small number, look what happens. All right. Just because I know some of you, it's been a while since you've done any math or thought about why did they teach me all this stuff, in math class. But see, in other words, if we take 1/2, that equals 0.5. If we take 1/4, that equals 0.25. All right. So the bigger the number gets here, the smaller the outcome. So if I take a small number, so if 1 divided by 0.2, well, that equals 5. 1 divided by 0.1, that equals 10. 1 divided by 0.001, that equals 1,000. So when this number gets really, really dinky, boom, you get a huge number. So that force, so when we go back to this, so if we're going to find the force, we take the change in the momentum, and then we divide by this dinky time, and we get a huge force. Okay, golf ball hit, tennis ball, forehand, millisecond. All right, I'm actually using things that I've looked up on the internet, so they've got to be true, right? No, it's from some physics sites on the impulses that you're going to be doing. You're going to be looking at 3 things in this exercise. You're going to be looking at Serena Williams hitting the serve. You're going to be looking at a baseball getting hit by a bat, and you're going to be looking at concussion, at a head-to-head collision in football, in the NFL. Okay, and the percussion and the repercussions of these concussions too. We'll talk about that. And this is when I wish we had a live class so we could actually discuss some things, because there's a lot of social justice issues involved in this, and a few other things. All right. So here you go. Object moving. In other words, when you want it to stop, if you don't ride the punch, it hurts. Ouch, because it stops so quick. But if you expand that time of the collision, then it doesn't hurt so much. That's why there's padding in helmets. But that's why there's not padding on a bat. All right? Because you want it to fly off. Okay. So you understand you want to bend your knees. You want to have a soft landing. Someone tosses you an egg, you just naturally. We're all natural physicists. That's what I love about physics. We're all natural physicists. We just make it hard when we throw in all this math, but we're going to work that out. So this is track 2, and we'll stop here. I get excited about this, and I kind of go on.